median of grouped data. In this module, we will introduce median of grouped data. We know that the median is defined as a measure of central tendency which gives the value of the middlemost observation in the data. For finding the median of ungrouped data, we first arrange the data values of the observations in ascending order. Then, if n is odd, the median is the n plus 1 by 2, and if n is even, then the median will be the average of the n by 2th and the n by 2 plus 1th observations. Now, we will find the median of grouped data. It is to find the value inside a class that divides the whole distribution into two halves. But which class should this be? To find this class, we find the cumulative frequencies of all the classes and divide it by 2. We now locate the class whose cumulative frequency is greater than and nearest to n by 2. This is called the median class. In this distribution, n is equal to 53, so n by 2 is 26.5. Now, 60 to 70 is the class whose cumulative frequency 29 is greater than and nearest to n by 2, that is 26.5. Therefore, 60 to 70 is the median class. After finding the median class, we use this formula for calculating the median. Median is equal to L plus n by 2 minus cumulative frequency upon frequency into h, where L is equal to lower limit of median class, n is equal to number of observations, Cf is equal to cumulative frequency of class preceding the median class, f is equal to frequency of median class, h is equal to class size, assuming class size to be equal. Substituting the values n by 2 is equal to 26.5, L is equal to 60, Cf is equal to 22, f is equal to 7, h is equal to 10. In the formula, we get median is equal to 60 plus 26.5 minus 22 by 7 into 10, which is equal to 60 plus 45 by 7, which is equal to 66.4. So, about half the students have scored marks less than 66.4, and the other half have scored marks more than 66.4. Example. The median of the following data is 525. Find the values of x and y if the total frequency is 100. First of all, we will find the cumulative frequency. It is given that n is equal to 100. So, 76 plus x plus y is equal to 100, that is, x plus y is equal to 24. Let it be equation 1. The median is 525, which lies in the class 500 to 600. So L is equal to 500, F is equal to 20, CF is equal to 36 plus X, H is equal to 100. Using the formula, median is equal to L plus N by 2 minus cumulative frequency upon frequency into H, and putting values we have 525 is equal to 500 plus 50 minus 36 minus X upon 20 into 100, which implies 525 minus 500 is equal to 14 minus X into 5, that is 25 is equal to 70 minus 5X, which implies 5X is equal to 70 minus 25 is equal to 45, that is X is equal to 9. Therefore, from 1 we get 9 plus Y is equal to 24, which implies Y is equal to 15. Now that you have studied all about the three measures of central tendency, let us discuss which measure would be best suited for a particular requirement. The mean is the most frequently used measure of central tendency because it takes into account all the observations and lies between the extremes, that is, the largest and the smallest observations of the entire data. It also enables us to compare two or more distributions. In problems where individual observations are not important and we wish to find out a typical observation, the median is more appropriate. Example, finding the typical productivity rate of workers, average wage in a country, etc. These are situations where extreme values may be there. So rather than the mean, we take the median as a better measure of central tendency. In situations which require establishing the most frequent value or most popular item, the mode is the best choice. Example, to find the most popular TV program being watched. There is an empirical relationship between the three measures of central tendency. That is, 3 median is equal to mode plus 2 mean.